Welcome to our journey through the solar system. In this video, we'll explore the wonders of our cosmic neighborhood, starting with the heart of it all, the Sun. The Sun, a yellow dwarf star, is about 109 times bigger than Earth, and its surface is incredibly hot, reaching thousands of degrees Celsius. It's not just a fiery ball in the sky, it's also the lifeline that sustains life on Earth. The atmosphere is primarily composed of hydrogen, followed by helium, with smaller amounts of other elements. The Sun is structured into the following 6 layers: the core, where fusion powers energy; the radiative zone, where photons move outward; the convective zone, involving plasma heat transfer; the photosphere, emitting light and heat; the chromosphere, featuring prominences and flares; and the corona, the source of solar wind, observed during eclipses. An interesting fact is that the Sun accounts for approximately 99.86% of the mass of the solar system. Before we talk about each planet, let's explain 3 important terms applicable to all of them. Earth's distance from the Sun, on average about 150 million kilometers, is also known as 1 astronomical unit. The time it takes for a planet to complete one orbit around the Sun in the solar system is called its orbital period. On the other hand, the rotational period of a planet refers to the time it takes for one complete axis rotation in the solar system. Let's start with Mercury, the closest planet to the Sun. Mercury, a small rocky planet, experiences scorching temperatures. Despite its diminutive size, it completes a rotation in about 59 Earth days. It orbits close to the Sun at a distance of about 0.39 astronomical units. The atmosphere consists primarily of oxygen and sodium, followed by hydrogen, helium, and trace amounts of potassium, and other elements. Mercury's structure consists of 3 main layers: the crust, a thin layer of rock; the mantle, a solid layer, possibly partially molten; and the core, likely composed mostly of iron. An interesting fact is that Mercury holds the title of the smallest planet in the solar system. Moving on, we have Venus, often called Earth's sister planet. Venus, known for incredibly high temperatures due to its thick atmosphere, completes a rotation once every 243 Earth days. It orbits closer to the Sun than Earth at a distance of approximately 0.72 astronomical units. The atmosphere is overwhelmingly composed of carbon dioxide, with trace amounts of nitrogen and other elements. Venus' structure includes the following layers: the crust, a thick, rocky outer layer; the mantle, a semi-fluid layer beneath the crust; and the core, possibly composed of iron and nickel. An interesting fact is that Venus spins slowly in the opposite direction from most planets. Earth, our home, comes next as the 3rd planet from the Sun. Earth, the only planet known to harbor life, with moderate temperatures and abundant water, completes a rotation in approximately 24 hours. It orbits the Sun at an average distance of 1 astronomical unit. Earth's only natural satellite is commonly known by the simple name, the Moon. The atmosphere consists primarily of nitrogen and oxygen, along with trace quantities of argon and various other elements. Earth's is made up of the following layers: the crust, Earth's outer layer, continents and oceans; the lithosphere, a firm upper layer including the crust; the asthenosphere, a semi-fluid layer under the lithosphere; the upper mantle, extending about 670 kilometers below the Earth's surface; the lower mantle, a deeper layer of the mantle towards the core; the outer core, a liquid layer of molten iron and nickel; and the inner core, a solid center of iron and nickel. An interesting fact is that over 70% of Earth's surface is covered by water, making it the blue planet. Fourth in line is Mars, known as the red planet. Mars, recognized for its rusty surface and polar ice caps, completes a rotation in about 24.6 hours. Situated further from the Sun than Earth, at approximately 1.52 astronomical units. Mars has two moons. The first larger moon is Phobos, and the second is Deimos. The atmosphere is mostly made up of carbon dioxide, with smaller amounts of nitrogen, argon, and trace elements. Mars' structure consists of the following three main layers: the crust, a thin layer of rock; the mantle, a solid layer beneath the crust, possibly with some molten rock; and the core, likely composed mostly of iron. An interesting fact is that Mars is called the red planet due to the presence of iron oxide in its soil. Now, as we journey past Mars, we find the asteroid belt, located between Mars and Jupiter, full of rocky objects. Among the most interesting are Ceres, a dwarf planet, and the large asteroids Vesta and Pallas. Now let's journey to Jupiter, the largest planet in our solar system. Jupiter, known for its colossal size and powerful gravity, spins through a rotation in under 10 hours, making it one of the fastest spinning planets. It orbits the Sun at a distance of about 5.2 astronomical units. Jupiter has 95 known moons, with the four largest known as the Galilean moons: Callisto, Ganymede, Io, and Europa. The atmosphere is predominantly composed of hydrogen, with helium as the second most abundant element. Jupiter's structure includes the following layers: the clouds, Jupiter's atmospheric clouds; the gaseous hydrogen, the outermost gaseous layer; the liquid hydrogen, above the metallic hydrogen layer; the metallic hydrogen, compressed hydrogen in a metallic state; and the core, a dense core of heavy elements. An interesting fact is that the Great Red Spot is a giant, spinning storm in Jupiter's atmosphere. Sixth in our journey is Saturn, famed for its rings. Saturn, composed of ice and rock elements, presents a sight with its magnificent rings. It completes a rotation in about 10.6 hours and orbits the Sun at a distance of approximately 9.58 astronomical units. Saturn has 146 confirmed moons, the largest being Titan, followed by Rhea, Iapetus, and Dione. The atmosphere is mainly composed of hydrogen, followed by helium, with trace amounts of other elements. Saturn consists of the following 5 layers: the clouds, the visible atmospheric features of Saturn; the gaseous hydrogen, the outermost gaseous layer; the liquid hydrogen, above the metallic hydrogen layer; the metallic hydrogen, compressed hydrogen in a metallic state; and the core, a dense core of heavy elements. An interesting fact is that Saturn's rings are composed of billions of rock and ice chunks orbiting the planet. After Saturn comes Uranus, known for its unique tilted axis. Uranus, with its mix of ice and rock, stands out with its awesome blue-green color. It completes a rotation in about 17.2 hours and orbits the Sun at a distance of approximately 19.22 astronomical units. Uranus has 28 moons, with the most prominent being Titania, followed by Oberon, Umbriel, Ariel, and Miranda. The atmosphere is primarily composed of hydrogen and helium, with methane as a notable component contributing to its composition. Uranus is made up of the following layers: the clouds, the visible atmospheric features of Uranus; the gaseous hydrogen layer, the outermost gaseous layer; the liquid hydrogen, above the mantle, where hydrogen exists in a liquid state; the mantle, a surrounding layer, possibly icy and rocky; and the core, a dense core of heavy elements. An interesting fact is that Uranus rotates at a nearly 90-degree angle from the plane of its orbit. Finally, Neptune, the farthest and bluest planet. Neptune, the farthest known planet from the Sun, has a dynamic and ever-changing atmosphere. It spins around once every 16.1 hours and hangs out way far away from the Sun at about 30 astronomical units. Neptune has 16 moons, including its 4 largest satellites: Triton, Proteus, Nereid, and Larissa. The atmosphere is primarily made up of hydrogen and helium, with a small fraction of methane gas contributing to its composition. Neptune's structure includes the following layers: the clouds, the visible atmospheric features of Neptune, the gaseous hydrogen layer, the outermost layer of Neptune, the liquid hydrogen, above the mantle, where hydrogen exists in a liquid state, the mantle, a surrounding layer, possibly icy and rocky, and the core, a dense core comprised of heavy elements. An interesting fact is that Neptune has the solar system's fastest winds, up to 2,000 kilometers per hour. Beyond Neptune's orbit lies the Kuiper Belt, home to many icy bodies, including dwarf planets. The most famous is Pluto, followed by Eris, Haumea with its unique shape, and bright-surfaced Makemake. As we journey to the farthest corners of our solar system, we find the Oort Cloud, a vast sphere up to 100,000 astronomical units from the Sun. It's believed to be the birthplace of long-period comets. We often see planets displayed as similar in size for clarity, but in reality, their sizes compared to each other look more like this. Let's summarize the two main types of planets in our solar system. First, we have the terrestrial planets, the four inner planets closest to the Sun. They have rocky surfaces and are smaller and denser. Next, we have the Jovian planets or gas giants. They are much larger but less dense, with thick atmospheres of hydrogen and helium. The huge distances between planets and their relatively small sizes make it hard to show both accurately. Usually, we focus on either size or distance in pictures. Remember, planets are always moving around the Sun. As we conclude our journey through the solar system, it's clear that its wonders are endless. If you enjoyed this video and want more captivating content on space and beyond, remember to like and subscribe. Thanks for joining me, and until next time, keep looking up.